first we will be going through what is Azure, and then there will be a comparative study between Azure and AWS, and we'll see what are the advantages of Azure over AWS. Next, we will see the outcome of the Azure Data Engineering Associate course and introduction to your non-relational data stores or the NoSQL databases. Then, once we understand the concept of non-relational data stores, we'll understand why NoSQL or non-relational database came into picture, why we are using it, why we go to that. Next, we will understand when to choose a NoSQL DB and when to choose this NoSQL DB and when to choose the relational DB. So let's start with what is Azure. So basically, Azure is a cloud computing platform and an online portal to access and manage resource and services provided by Microsoft. So that is the definition. So if some, and to understand it in simple terms, so for someone for who is listening to this term first time, let's compare it to something like let's compare it to something of our phone networks. So none of us have the complete ability to go and create a network end to end. Like we cannot go and set up the towers, we cannot pull the lines, we cannot create a complete network on our own. So what exactly we do? We just choose the plan which suits our needs, and then we go and we subscribe to that. So we pay them for the subscription which we have taken, we use their services, and then accordingly we pay them. So the exact similar concept is used here in your Azure cloud. So what happens, there are organizations such as Microsoft and your Amazon who provide us with cloud platforms which can be accessed over the internet. What happens is such organizations such as Microsoft and Amazon or Google, who are providing us with cloud platforms. So we as a cloud consumer, we just need to go over the internet and access their online portals, and they provide us with all the different kind of services that we require for the cloud platform, cloud computing. So here we do not incur any infrastructure cost, because the setup of the data center or the server or your maintenance of your softwares, everything is taken care by Azure. All you need to do is select the resources which you need, the database which you need, you can select of the different, even you can select on different kind of configurations. They even give you an option of scalability, which is both scale in and scale out. By scalability, I mean something like, suppose you have created a database of 2 TB and suddenly the need increases. So just with a few clicks, you can increase the database size. And similarly, once you feel that you're not using the database completely and you want to release some space, the same thing can be done with a few clicks. So these kind of features are available to us. So this is what we mean by cloud computing, and Azure is the platform that is provided by Microsoft. So yeah, as I said, Azure is used to build, manage, and deploy applications on massive global network using your preferred tools and frameworks. So it's not only about your databases, you can also create different kind of app services over there, or different web applications, or whatever your need and necessity is. So you can just go to the portal and select the resources, whatever is required, and then we can build in that and we can deploy, and you can create your own applications. So these are a set of cloud computing services to help your organization meet your business challenges. So as it is said here, so once whatever is your requirement, accordingly you can build and create the resources in cloud. Okay. All right. So now we'll move to understand why we are moving to Azure or to cloud platforms. So what happens is they have data centers. So what are data centers? I hope all of you know. So data centers are places where your data is actually stored, the physical place where the servers are located and all. So what Azure does, it provides us data center not only in one single place, but as you can see, its data centers are in 42 different regions across the world, and this number would have increased by now for sure. So because they are adding data centers, like data centers are being added every now and then. So in India itself, it has 3 data centers. So since your so many places has your data centers, so your data can be accessed from any part of the globe, and can be accessed very fast. So this is the benefit of having data centers across the globe. All right. So next is your security. So whenever we move data into the cloud, the security is one of the major concerns. Because any organization, it will think many times before moving your data from this on-prem, which is very secure, to the cloud. So all kind of cloud providers provide us with lot of security for your data in the database. When the data movement is happening, for all kind of data, it will be highly secure. Apart from that, for data encryption, they use a very high-ended algorithm. And suppose we want to introduce our own algorithm, then we have an option to do that as well. So when we will be creating your storage accounts or other databases, whenever we get this option of security, I'll show you that how we can select the encryption details. So the next feature is scalability. So as I said, scalable is something wherein, or scalability, you can relate it to the elasticity. So it is something like your resources are scalable both in and out. So whether it is your database or you have created a virtual machine with certain computational power, and then you don't need it like that. So you can just reduce the computational power, or you can reduce the size of the database. So imagine if you have to do it on an on-prem server, it's not impossible, but it is a big process to increase the size of your database. But here it is not like that. And this is not just for database or for virtual machine. For any resource, whenever we create in cloud, they provide us with this feature of scalability. Next is your hybrid capability. Now, this is a very important feature, because what happens is, say any kind of organization, so it cannot move its entire set of data in one day from on premises to cloud. So it is kind of a gradual process. So what happens, your some data is in the on premises and some data is on cloud. So your on premises data is something called as private cloud, because it is completely managed by the organization. Any person who is over the internet cannot access that. But the data on your cloud, which is provided by, consider on Azure. So it is on a public network. So any person over the internet, if he has the access, if he is authorized for that data. So as I said, through security, we can give different levels of authorization. So we can check on who actually can access the data. So if you have that authorization, you can go ahead and see the data. So what happens is, most of your data is on premises and slowly you are migrating some of your data on cloud. So when the structure is like this, it is called hybrid cloud, and it provides you with this hybrid capability. So you don't need completely to move everything into cloud to use cloud. So that is one very important feature. And next is flexibility. So it is highly flexible, and so you can access it from any kind of device. You need not be in on premises or in a particular place, or you need not connect to a particular network to access to the cloud. All you need to have is a system and an internet and the connectivity to the cloud. So that is all you need. So with these kind of features, it becomes very accessible. Its availability is high, so it's scalable. So that is why people or organizations have started moving from your on premises into cloud. Okay. So the next is, we'll check on the advantages of Azure over AWS. So AWS is Amazon Web Services, which is the cloud platform that is provided by Amazon. So slowly, Microsoft Azure is coming up as one of the most trusted cloud enterprise and for hybrid infrastructure. So many companies are moving into Azure cloud nowadays. So let's understand why Azure, on what basis Azure is more advantageous when compared to your AWS. Now, what the first thing is, AWS is 5 times more expensive than Azure for Windows Server and SQL Server. So even AWS will provide you Windows Server and SQL Server, but when the cost comes into picture, here AWS is giving you it for 5 times less expensive. Then there are other services and platforms for which Azure and AWS, the pricing is comparable. So in this case, if someone has to use a Windows Server and a SQL Server as the major thing, so they will obviously prefer Azure as it is cheaper. So Azure allows you to use any kind of open source language or software and or tools on Azure. So the Databricks, which we have heard, so there you can easily write your code in Scala, which is again an open source, right? So this way you can leverage open source along with Azure. So it's kind of an advantage. And then there is a fact like Azure made the most contributions to GitHub in 2017, and it is the only cloud with integrated support for Red Hat. So GitHub is your repository where all the code resides. And what do we mean by integrated support is, see, in the cloud you will have various different kind of services. So these applications may not be owned by Microsoft itself. They can be owned by different companies. So if it has an integrated support, what happens is you can directly reach to Red Hat. If you have any issue with Linux, you will directly reach to Red Hat instead of going via three channel that you have to go to first to Microsoft and then they will contact. So this increases the pace at which the issues are resolved, or if you want to learn something or ask something, it's very fast in this case. So one of the other reasons that Azure stands above AWS competition in the gladiator ring of cloud offering, its compatibility with the programming language .NET. So .NET is one of the programming languages through which we can code in Azure. And so someone knowing .NET application can very easily develop apps, web apps, or your other kind of applications in Azure. And then since hybrid cloud is something which is now majorly going on, so hybrid consistency is a key differentiator between AWS and Azure. So you can hit the ground running if you choose Azure over hybrid cloud requirements. So as I already said that it's not possible for any organization which is already there to move all its data, all its applications, all its functionality into cloud. So everything will have to go through this hybrid model. So then Azure provides a better feasibility for the hybrid models. So this course is basically set around Azure DP 200 and 201 certifications. So both these certifications combined give you the Azure Associate batch. So there are three batches: Azure Fundamental, Azure Associate, and Azure Expert. So Azure Fundamental is AZ 900. And when you this is something related to the data engineering associate as well, it gives you the Azure Associate batch. So this course will prepare you for these two exams, that is DP 200 and 201, for implementing and designing Azure data solutions. It will enable you to architect and execute the management, monitoring, security, and privacy of data using the full stack of Azure data services for major business needs. Now you need to understand one thing, that there is no concept of admin, or someone one person will take care of the infrastructure, one person will just design all the schemas, and one person will do the development. No, a one single person can do everything. So through these two courses you will learn what all the resources are there for the data related work which we do in Azure. You will learn to implement it and you will learn to design it. All right. So Azure DP 200 is implementing an Azure data solution. So candidates for this exam are Microsoft Azure data engineers who collaborate with business stakeholders to identify and meet the data requirements to implement data solutions that use data services. So someone who is DP 200 should be able to implement the solution. He may or may not be able to design the complete solution. Whereas DP201 is for someone who is able to design the data solutions for Azure data services. All right. So who should take this course? This course is ideal for anyone who wants to start a career in data analytics or is already working in the following roles, like the data engineers, data architect, data scientist, or data analysts. And the next few slides is showing up how much will be a basic salary or an average salary of people who are working in these fields. Like for data engineers, the average for fresher and experienced is mentioned over here. And then the same thing is mentioned for a data architect level. And then for a data scientist also we see the different salaries, the average salaries. This comes from a market study, and of course it can vary. And then for data analysts, what you can expect both in US and in India. So post this course, the skills which you will learn is storage. The storage is the different kind of storages we have. Now see, cloud provides you with the NoSQL databases, SQL databases, your blob storages, your data lake storages. So all these kind of storages will understand what it is and will design it, will create these things, and will do a use case on each and everything. Then we'll move on to your processing. So in this processing comes your Azure Data Factory and your Azure Databricks. Okay. So Azure Data Factory is something which gives you more kind of a GUI feel, and you will have activities which you can create, and then you can actually do the transformation or the load. And Azure Databricks, it gives you workspaces wherein you can write the complete code in four. They provide you with four languages, which is Scala, Python, R, and SQL. So you just have to, there's a way to define which language you will use, and then you can write the complete code in that particular language. These two are the platforms which provide us with the processing. Next is your monitoring. So there are various different ways in which we can monitor. First of all, your Databricks, Data Factory, they themselves have their individual monitors where you can see how the job is running, how much time it is taking, and all the details which we usually see in the kind of in any kind of ETL jobs. All right. And apart from that, your Azure also provides monitoring and advisory and logs, all these things on the Azure level. Apart from these two products, like the Data Factory or the Data Flow. So the cloud level, at the subscription level, you can actually see what it is. All right. And then the security, which is a very important feature, because obviously once we have moved our data into cloud, we won't like people or anyone to have access to it, right? So how we restrict access, what all options do we have to restrict, options do we have, how do we set up a firewall across it, and all those how we so all those things will be going through in this session. Okay, so as you can see here, there are storages. So you have non-relational and relational. So this is non-relational is what I meant when I said NoSQL DBs. And here we have your Cosmos DB, your ADLS, which is Azure Data Lake Storage. And so ADLS was in the older version. Now we use ADLS 2, which is a combination of ADLS and blob storage. Right? And blob storage is another kind of storage, non-relational storage, that is provided by Azure. Then again, every for a relational data, if we have a relational data, using a NoSQL database is never suggested, right? So we need to have the relational databases also. So there is something called as Azure SQL DB. Then you have Azure Synapse. So this is basically your Azure SQL data warehouse. In the newer version, it is known as Azure Synapse. So initially it used to support only relational database, but now this feature helps you to connect to both relational and non-relational database. And then you have the elastic pools. So I was saying you about scalability, right? So how do you scale up? And this elastic pool helps you with that.
So as we know, like about relational databases like SQL, Oracle, so there is a language called SQL, say
Right.
NT-SQL, PL/SQL kind of thing.
Correct.
For non-relational databases, especially for Cosmos DB or
Hmm.
ADLS, so
Hmm.
is there any kind of SQL kind of query we are going?
Okay, so you want to know how you will access that data, right? Basically, how you will
Yeah.
write in that data, right? So see,
Yep.
directly it's not something like it does not support SQL. Okay, non-relational database is not something which will not support SQL. So what happens when we'll create a Cosmos DB, we can select which kind of Cosmos DB we want. So we can select with the SQL API. So when we do that, we can use SQL to access Cosmos DB, at least to see the data. Okay, and
Okay.
regarding your ADLS and your blob storages, there are other ways of accessing it. I'll definitely show you when we create the data sets, we can see in that.
Sure. Thank you.
So next comes your processing. As I told you, you have your Azure Data Factory, which we will be going in detail on what exactly is your Azure Data Factory, why do we need to use Azure Data Factory, and what all we can do in Azure Data Factory. So this is basically, it will help you. So Azure Data Factory is something, it will help you to connect to any kind of source. Okay, whether it is a relational, it comes from a relational database or it comes from a non-relational database, and then it will help you to do a transformation on all of these data. Like what happens, we don't need to create a third layer. So usually what is the thing, we get a data from different sources, we bring it in a place where the data is of the same kind, that processing we have to do, and then we start processing it. But here we don't need to do it. Simply we can create link services which are like connections to the different kind of data stores which we have, fetch the data, do the different kind of transformations which we want to do, and load it. Or else you can directly fetch the data and load it. So it provides with lot of different kinds of activities, and we'll go through it. So the
Yeah.
next one is your Azure Databricks. So Azure Databricks is it also helps with your ETL things, but here you can write the code. So it is a the way it works is different. The way we write the code is different, but again you can achieve the same transformality. All right. And as you were asking, Azure Stream Analytics, it is a serverless, scalable, complex event processing engine by Microsoft. So you can run these analytics on your real time data, on multiple streams of data which are coming from different sources like devices, sensors, websites, social medias, etc.
So all these things are tools like Azure Data Factory, Data Breaks, and Stream Analytics. Like
These are
what are the
platforms. Yeah, these are
platforms?
platforms
Okay.
where, yeah, these where you can create. All right.
Okay.
So yeah, in cloud you have a concept called like services, like software as a service. Now there are three things, three major things in that. One is infrastructure as a service, platform as a service, and your software as a service. All right. So cloud Azure provides these three things. So when we talk about infrastructure as a service, what it does is all kinds of underlying infrastructure setup is done by your Azure. You need not do anything. You did not create any server, you need not buy any kind of application, you do not do any kind of software licensing. You don't need to do any such kind of things. So everything is taken care by Azure. That service is called infrastructure as a service. Now platform as a service is something where it gives you different, it provides you with platforms to create your services. All right. And the next thing is your software as a service. There is different kind of software such as Office 365 and all. They are they're already available in your portal. So who gets that? Who gets the licensing? Who is responsible for maintaining it? So all that is done by your Azure. So these are
So
basically three important services. Okay. So the next thing is your security. So there are two kinds of security things that are mentioned over here. One is your data masking and then your encryption. So data masking is something wherein we don't want the exact data to move from your on premises into your cloud, right? So that is something called as data masking. And then encryption is also provided. You can encrypt your data all the time, even when it is in transit or when it is stored. And when we will create the storage services, right, we can go through it. Okay. So your next thing is okay. So let's move on. Actually, do all of you have your free accounts?
Yes.
So
No,
does
no, I don't have.
Okay, fine, fine. No issues. It's very simple. So just log into 1 second. I should have. I actually opened and kept. Need to search this Azure sign in, and you just need to have a Visa or a Mastercard for the initial one. All right. You just go to this site, Microsoft Azure site. So here you can just click on Start Free. All right. If you click on this Start Free button, so since I've already logged in, it is showing this page, but otherwise it will ask for your informations. All right. So we'll do one thing like this. It is like all these details will be there. So for you, more
No,
things will come. Your name and PAN card detail and other details. Since mine is stuck at this particular page, it is showing here.
I have already created this and credit already consumed now. So can I
Okay.
create another one for same credit card?
I know I don't think so. You can, because it will ask your PAN number also, right? You for the same credit card you can't.
So
So
how is Microsoft monitoring this? Because I've used previously, I've created one, and I was not
mhm.
able to use the same thing again. So is it email ID, or do they check the Visa
So
card details, or?
so if you will log in here, right? Just a second. What I'll do is I'll just log in again and show you. So it will ask apart from your name, it'll take PAN card number also. Okay, so this will be the page where you can see, and so this is the subscription. So yours will be a free subscription, and you can see the credits. And so these are all. Once we start creating the resources, right, it will start showing up over here. So okay, so this is the portal is ready, and then will do you want me to create something and show it to you, like how it looks or anything like that, or shall we just start with the NoSQL database?
Start with NoSQL actually.
Okay, fine. All right. So let's start with the non-relational database. So all of you here know about the relational databases, right? Is there someone who does not know what a relational database is? Okay, so I suppose everyone knows a relational database. So why does the NoSQL or non-relational database comes? So first of all, NoSQL does not means that this database does not use a SQL. You can relate it to something like not only SQL. All right. So why do we need NoSQL databases or non-relational databases? So let us first understand its necessity. So, from the last few years, the amount of data on which we are working, or which different kind of applications are producing, is very huge. So, your social networking sites like say Facebook, LinkedIn, Instagram, they provide huge amount of data, and just they don't only provide huge amount of data, you also need them to access at any point of time. Say your or your search engines, so it's not something like once a data is created, you will not access. So the data is huge. You have to access it access it in a very small, having a very small latency. It should be always up and running. You have to do transformations on that. You have to develop your analytical algorithms on that. So when all this came into picture, right, the relational database was not able to support it that way. So then came the concept of non-relational databases. So, as the name suggests, right, it is a database that does not use your tabular schema of rows and columns found in the most traditional databases system. Here, there is no concept of row, column, table, schema. So, there is no concept that, see, in a relational database, suppose we have an employee column with just your employee name and employee ID. So all the data in your employee ID column should be of the same data type. Employee name should be of the same data type. You can have only two columns. The data can have only two fields. So these are the limitations. What happens in a non-relational database? First of all, you can have a one single record can have n number of different attributes, and the next record may not have the same n number of attributes. It can have less, it can have more, it can have different. So one record is stored as one single record need not be same as another record. But here, suppose to make it more clear, suppose we are getting data of employees of a company. For employee one can have records coming in, details will be like his ID, his first name, his last name, and his age. The second employee details may be employee's first name and last name. There may not be a column of age alone. There may not be any input of age. All right. The third employee may, apart from first name, second name, last name, age, he may have address details also. So you can store all kinds of data. So this is why it is called non-relational database. It's not, that's not a structured database. So how are the data stored here? Because in relational database, we know that it is stored in your tabular format. We have rows and columns, and we can run your SQL on that. So here they are stored as simple key value pairs, or as JSON documents, or as graphs consisting of edges and vertices. So based on the way the data is stored, we have different types of NoSQL or non-relational databases. Alright, they use a storage model that is optimized for specific requirements of the type of data being sorted. Now, when a non-relational database comes into picture, so based on the requirement, we have a different database, a different kind of database. We cannot use the same kind of NoSQL database for all kinds of non-relational data. Okay.
So when you say it is not same kind, uh,
Mm-hmm.
so what does it mean? Like Cosmos DB, what's the difference between Cosmos DB and any other DB?
Yeah, we'll go through that. Okay. So see, there is something called as a document DB. Then there is something called as columnar DB. There is something called as key value DB. So what happens is the way you are storing the data, right? That changes. So you, there are various different kinds of cost databases. You can see here, right? There's Influx, Timescale, Prothemus, MongoDB, Neo4j. Now Neo4j is a graph database. Okay. MongoDB is a document database. Cosmos DB, that provides you four kinds of API. So that is one additional feature which Azure will provide. So you can use Cosmos DB as a document DB. You can use it as a with a SQL API. you can use it with a graph as well. So see, the way the data is stored, the way it is accessed, it is different. So the term, as I said, the term NoSQL refers to data source that do not use SQL for queries and instead use other programming languages and constructs to query the data. Someone was asking me how we query the data. Okay, so in general, say you are not using Cosmos DB or you're not getting the Azure platform. So there are different ways to query it. Okay, now when it is a document DB, your data is generally written in a JSON format, so you can see the data in that particular format. Again, when it is a graph database, it is according to graphs and nodes, so then you can see that thing. But the good part in Azure is it provides you something called as Azure Storage Explorer. So in that you can see whatever storage accounts you have created, and you can see that is for the storage accounts. Then for Cosmos DB also you can see it through that. I'll show it to you. Okay. NoSQL means non-relational database, even though many of the database do support SQL compatible queries. That's what I was saying, that they do support. Even Cosmos DB, you can query it through using SQL. However, the underlying query execution strategy is unusually very different from a way a relational RDBMS would execute the same query. So let's understand what are the different types of databases and how the data is stored in that and how we get the data back from that. Okay.
Is it, are you going to use the USQL something I heard?
Yeah, there is a thing called USQL. So through USQL, see, data lake is a non-relational database, right? But using USQL, you can query it. So that is what is a USQL activity that is present in your data factory.
Okay, thanks.
Okay, so next we move to the different types of non-relational databases. So we have your document data stores. Then first we have your document data stores. Then you have your columnar data stores. You have your key value data stores, your graph data stores, time series data stores, object data stores, and external index data stores. These are the 7 different types of non-relational databases which are available. We'll start with your document data stores. What is a document data store? Before we go into the detail, I'll show you how the data actually looks. Okay. So you can see here, this is one set of customer details. So there is just forget the key or anything. I just concentrate on the data that is coming. So what happens? Your first data is a customer ID of 99. Then he has certain order items. Now there are 2 or more order items. All right. So see, there are an array of these order items. The first you have one product, quantity and cost. Then you again add a nested loop in it, and you add another product ID, quantity and cost. Similarly, you can add more. And then you have the order date. If you see the next customer, so you have your customer ID, again order details. So here it is the same thing, but you can again have an additional field, or you may not have all the 3 fields. And then you have the order date. You can again have this field, or you can have additional fields like order day or expiry date or any such thing. So this is how the data will come in. So you can relate to a non-structured data now, how it looks or how it basically comes into the database. How we store it, I'll go through that. But generally, a data will look like that. Am
But
I
Shweta,
audible?
there is only one difference in 10001, 102 that
Huh.
in 10 for this customer 99, it is having 2 orders.
Right, right. See, this is an example which is showing. Okay. But
Mhm.
if I want, I can just take this.
You mean to say that fields may be more or less, right?
Right, fields may be more or less. So this is like this, right? Customer ID and your order ID, your order date. So here you see there are 3 things. All right. So I may have something like this. So instead of product ID, I may not have this quantity
So
column.
Shweta, basically
I may
this
not
data is
have. This data is in JSON format.
Oh, okay, got it. Got it.
I so the thing is, it may not always be in a JSON format. I just want you all to know like how different it is from a SQL database. So in SQL database, we cannot think like this, right? And then this particular this whole thing is one record.
But tell me
Okay.
one thing,
Yeah.
Shweta, when we are storing this data
Hmm.
into database, which is having the document as the, so there we don't define any sort of a predefined structure or no. We
No, we do
simply
not.
store like a JSON format.
Yes, we do not define. We need not define the schema beforehand.
Okay.
Okay,
And it is
so
having only two columns?
no. It can have n number. Oh, yeah, key
No.
and
Key and
document.
document.
Yeah,
Key document.
yeah, right. It will
Something
have.
like a key
So
value pair, something like we have a key document.
yeah, so key value pair will come again. Key value pair is little
Yeah.
different. Okay, so here what happens is, like we have rows in your database, the level that same document is at the same level. So now let's understand what is the document data store. Okay, so a document data store manages a set of name string fields and object data values in an entity referred to as a document. So what they exactly mean is, so all the things, your entity and the entity details are inside one single thing, and that is called as your document. Okay, so these data stores typically store the data in form of a JSON document. 90% of the times it is a JSON document, but they also support XML, YAML, JSON, BSAON, or even stored as plain text. So there are different kinds of document databases also, and then based on your need you can store it. So usually when we select in a Cosmos DB as a SQL API, it stores it in this format and it uses JSON. Okay.
So for any document data store, it will just be in two column format, which would be a key and a document, right? For any n number of things.
Yes. And why we need the key is that also we'll go through it. Okay. So okay, there is a key and there is a document. Why exactly are we having the key? Let's see why it is needed. So the field within the documents are exposed to the storage management system, enabling an application to query and filter by using the values in this field. So what happens is, when you do a query, right, there exactly how you will mention it is, suppose we'll write select star from, say, this collection name or this item name is customer, where your, say, order date or customer, I will just keep customer c customer id as customer id as 220. Okay, this is exactly like how it is SQL, right? Because we will be choosing SQL API. But when you see the product, right, it will be showing you in this JSON format. It won't show in any tabular format for you. All right. So with here it will be, a single document might contain information that would be spread across several relational tables in a relational database management system. So this is what happened with me. So in our, like in the POC, one of the POCs what we were doing. So these kind of databases, right? They will have same, like, see, here in relational database what we have customer details in one table, we have order details in another table, and we have the date related expiry and all in another table, and we join them and we get the data. But this does not support that. So you cannot move directly your customer table and you're moving it into say you're moving to Cosmos DB, and it is getting loaded, you can see the data in a JSON format. Now when you want to get the order details, you cannot do a join in that way. They are not, it's not that simple to join. But here if you have all the data together, right, you need not normalize it. So data here is in a denormalized format. Okay, a document store does not require all the documents have the same structure. So as I was saying, there is no compulsion that how the first document is, the same document can be the same. It's not like that. So this document is something related to a, say, customer. That's all. So it can have all the details about the customer. You can do a join within the document. Now you can definitely join the customer ID, order ID here, because it is inside the same collection, same item. So when number of documents together, we call it as an item. So you can join it here. All right. But if you have two separate items, so two separate key and document pairs, you cannot join them. It's not that simple. You, okay. For example, yeah, go ahead.
Yeah. So if I have anything in the RDBMS, let's say the customer or let's say sales data I have,
Hmm.
okay,
Hmm.
and it's very difficult to move into the document, right?
Yeah, you have to get it restructured. So what usually people do is, usually the what they follow is, they use, what they do, they leverage the SQL DB and the SQL warehouse over there. Because see, again, one more thing is Cosmos DB is used when you require the data at a very, the availability should be very high, there should be very little latency. So these things can be used for your reporting purposes. Rather than in ETL we have the batch processing, right, where we just we store 24 hours data, or we just take the 24. Yeah, go ahead.
So while creating this document, I mean, you don't look at the structure at all, right?
No, it won't have the structure, and if you want directly one-to-one mapping, you need to restructure your RDBMS.
So migration is really difficult. I mean, in terms of if I'm moving from the RDBMS, okay, relational database to the document database, then
Yeah,
this migration itself is a difficult task, right?
but yes, it is a difficult task, but you need to know why exactly you want to move from a relational DB to a non-relational DB. See, your
Mhm.
Azure does provide you SQL warehouses also, right? Which are relational DB. So
One
there
of the
you can
reason I
just
know that people move to the NoSQL or non-relational DB is for the search, okay, and plus the
can you come again?
unstructured data they have.
Can you come again? Your voice broke in the middle.
Yeah, sorry. No, what I'm saying that people are moving from the relational to the non-relation
Yeah,
because
yeah,
of the search,
right.
fast
Okay,
search.
see, suppose, so then you have to design it in a smart way. Why do you want to restructure your data? You get the data, and
Mm.
SQL DB is a cheaper one compared to your SQL warehouse. Okay, you can get the data, you can create your SQL DB. Initially, you can set up with a huge configuration so that your data movement is fast. Once your data is loaded, then you can create what you want, right? No one uses all the data all the time every day, and the things which are used every day, we already have very small tables for that, so that the access is fast. So we need to, and we need to use each and everything, we have to understand. And actually, when your organization moves, like they take the Azure subscription and all, so you have a 24/7 support engineers, and apart from that they also provide you with expert level experts. So what happens is, when you design something, or when you need, they actually understand your requirement, and they can give you suggestions also. That, like I said, that if it does not require that you use your NoSQL database. You just, there is no necessity for you to move a data from SQL to NoSQL. NoSQL you only need to move when you will actually go ahead and use it. Say you are, what people, there are organizations, what they do, they actually start, instead of doing a batch processing, they will actually put a streaming layer. They'll start getting data through streams. And when you get data in streaming layer, or say suppose you are using Kafka mechanism to read the data, then you will get it in key value pairs. Then you can store it this way. So the source itself can be changed. Or else get the data, put it in a SQL DB over here, do the transformations, load it to a Cosmos DB. So you
Understand.
have to understand, like, and then there are, you have to be very clear on when you need to use which database. So that is why we need to understand each and every database properly.
Okay, sure. Thanks.
So, okay, applications can retrieve documents by using key. Okay, so with each document there'll be a key. So when we'll generate the Cosmos DB, right, it will, there will be one field where it will ask as key. By default we give it as ID. If you want, you can give your keys also, the, like, any columns you want to give from here or something like that. So this is a unique identifier for the document, which is often hashed to help you distribute data evenly. This application can also query documents based on the values of one or more fields. So one more thing, what happens is, why I said that doing a join between two different documents is very difficult, not two different documents, two different items is very difficult, is because what it has to do is, it has to retrieve your hash key of that particular record, go and search it, get that particular document, then search on the other item and do it. So it's a very expensive affair, and it takes a long time. So they always tell you to have a self join in the sense, I can always join customer ID, get the order details and the order date. Those three fields are here. If I add more fields, I can get that details also. Okay, so now let's see what all are there. So normalization, the data is denormalized. What about the schema definition? The schema is something which is on read. Okay, next is your consistency. So your consistency is tunable. You can actually control how you want your consistency to be. So to understand what consistency is, see what happens is, say, just consider your Cosmos DB only. Okay, so Cosmos DB is very very fast. There is a very little latency, and the moment you put a query, it returns the data. How it works? So internally in your Cosmos DB, there is already replication done. Okay. So when your replication happens, your data, that's how your data is accessed very fast. Okay. So and then one of the replica will be designated as a leader, and others will be other replicas will say as followers. When you do any kind of write operation, until the data is written in all these four places, it is not said to be written. Only once it is done, it is written. Okay, that is internally done in Cosmos DB. Again, what happens is when you define a Cosmos DB, you have an option of redundancy, where exactly you want the data to be copied. You want it in the multiple copies in the same region, across region, in different geographical regions. Based on your requirement, you can do the setup. Okay. Now it is you have the ability to choose how the consistency level should be. Okay, whether you want the data to be consistent across and how fast it should be consistent, or there, so those kind of things, it is tunable. Okay, see, imagine one of the data centers is in US, the other was in is India. So if the data has to move from US, that replication has to happen. They will take some time. So you have to decide whether how much consistency, whether your consistency is most important or your availability is most important, or you are okay with or the throughput is most important. Okay, this is a very detailed concept. I hope it is clear. I'll just give one more example. Say Facebook is there, okay, and my friends are there across. Someone is in US, someone is in Europe, and I am over here. So I posted something, and my friend in US is okay if the page loads a little late. He's okay with the latency, but the data should be consistent. Okay, so there he's giving an option. He's considering consistency over your availability. Okay, but the person is who is in London, he wants that the page should be up immediately, even though if the refresh is going little slow, let it happen after some time. So this is the basic concept on a non-relational database about consistency. This is across all non-relational database. So in document data store, you have the ability to tune this consistency. You can, the document level guarantees this. Okay, so since the data is stored in your document level, this consistency will be there. So your data will be consistent across all the regions you have given. So the atomicity, by atomicity we mean the row level in in RDBMS. So here it is collection. So locking strategy is optimistic. So do you know what locking strategy is? Let me go over that. So see, one thing you have to understand, that there will be always replication of data. That is how the data access is very fast. Okay, there. So what happens is locking, it refers to an action which basically prevents the data from changing between the time it is read to the time it is used. So data will be updated from various sources. Data will be coming from various sources, and some data may get updated. You do not want that one update has happened and someone has used, right? All the updates should happen, then someone should use, or when someone is using it, an update should not happen. So this is what is called locking. And then there are two types of locking strategies. One is called as optimistic and one is called as pessimistic. So the optimistic locking is that it assumes that multiple transactions can complete without affecting each other. Okay, and therefore one transaction can proceed without locking any kind of data resources. Okay, and so before committing any kind of transaction in an optimistic strategy, it verifies that no transaction is modified in its data. Matlab, it will cross check. Okay, and if suppose there is any conflicts, it is seeing that there is one transaction that has been, that is getting conflicts, that something is updated from one end and the same thing it's not able to relate to the other update, then it will roll back the changes. That is called as optimistic. So basically here they do not lock. Okay, and pessimist is the exact reverse. Here what will happen, they will lock the records and then they will update it. Okay, it assumes that concurrent transactions, if they do, it will conflict with each other. So they lock, they update, they lock, they update. Is it clear? Okay. So the next thing is how it is accessed. It's accessed in a random way. There's no need of a serial way. And indexing is, it supports both primary and secondary indexes. The data shape is a document, and the data is sparse. Okay, so and your datum size is small to medium, so it supports data which is small to medium size, and overall maximum scalable limit is very high. It's in petabytes. All right, so is this clear?
So
So when we
one more doubt actually. When we create in a Cosmos database, and
yeah,
there would be, can you come a little bit come down? So I have one single location database. There is no other secondary location for a read or write
yeah,
something.
yeah,
So how the
correct.
transaction works here? Single location database.
So you won't have that replication, right?
Yeah, will not have a replication here.
So see, the
Single
replication
location.
is done only. Yeah, the replication is done if you want to have for two reasons. One is data recovery. Say one location something happened, you still have your data somewhere else. And other is for the accessibility. So you will have a little less benefit on these two aspects.
Okay. So my consistency levels, how it takes, but for single location, not to multiple locations, the how
Then
it
it will
works.
then it will not come in that picture. See, then it data will be consistent, right? So this comes into picture when you have into multiple locations. In one region there is no replication. So obviously data will be consistent all the time, right? You will not have that issue that somewhere it is updated and the other way it needs to be updated, and it should be consistent across.
So for suppose a user is querying some data, so
Mm-hmm.
like he needs data from multiple documents to
Okay.
categorize the data. So still we can get how we can categorize the data to get that query. I mean, is that using the keys, only keys we can use by multiple documents, the data we can retrieve the data from the multiple documents, or how it is?
See, this thing is there'll be, like, suppose the in 1001 you see customer order and order date, right? Now suppose a user wants to know, so say which customer has ordered a product of ID 2010. Okay, since all the data is present in the document itself, you have all the fields. What will happen is a cross join will happen inside the document itself. It will do the join and will get the data for you.
Yeah,
Not in,
here
but
the joining by using
huh,
the document it will get join or
hmm.
a key ID. I mean that 1001. How it joins the data? For suppose a
Okay,
user
so I'm
querying some
using
data, querying the data.
huh.
So by
It
using the, yeah, please
key
go ahead.
key. It will use the hash key. So you will have
Hash
your
key.
indexes created. Yeah, yeah. It will use the hash key.
Okay.
So the relevant Azure service is your Azure Cosmos DB here. Okay, and so when we use the key value, I suppose there, if you see the example, you will have the same Cosmos DB but with a table API. Okay, so your Cosmos DB supports document as well and it supports key value as well. It just depends on the API we select. It supports the graph as well. So next come as the columnar data stores. Okay. So what happens is here instead of document we have column as the granular level. So a columnar or a column family data stores organizes data into columns and rows. So you see here. So this will be clear. You have a column family called identity. Okay. Then you have your customer ID here. Here you do not have a separate key or anything. You have a key value here. You have your first name, last name. Again, you see here, right? The structure has changed. You have first name, last name, and suffix. The third one, you have a title. Then you have another column family that is contact info. So here you have your phone number, email. Then you have, but here the ID is same. All right. It is actually, if you say the, it says, yeah, in the simplest form, a column family data store can appear very similar to a relational database, at least at least conceptually. So it is easy to relate in this one. The real power of a column family database lies in its denormalized approach to structure sparse data, which stems from the column oriented approach. Okay, so do you know what is sparse data? So let me tell. So what sparse data means is that suppose there are many gaps in data when it is getting recorded. Say for example, let's take the case of a sensor. The sensor may send signal, any sensor, okay, say a heat sensor, okay. Then a heat sensor may send signal only when there is a change in the temperature, right? It will not send signal anytime. So, and how we get sensor related data comes, the sensor related data and all is the data comes from IoT devices. So your IoT devices can also be connected in Azure and they send these kind of telemetric data. Okay. So I was saying about sparse data. So what happens is your data is being sent with some gap, right? One data has sent, again something changes, then the next will come. So this is a sparse data. So when your data is coming in, when your data is being sent as in this way, there is a gap or there's some, th- it's not sure when exactly it will come. So this is called as sparse data. Okay, and the reverse of this is called dense data. So that is the thing. So here what happens is this is very very useful when we are dealing with something of a data of a nature of which has sparse data. Okay, so columns are divided into groups known as column families, as you saw here. Okay, each they are divided into different kind of groups. Each column family holds a set of columns that are logically related and typically retrieved or manipulated as a unit. So you see here the identity is kept together. Again here the contact info is kept together. So we are not mixing an identity and contact info, we are not keeping it together, we are keeping it separately so that the logical grouping is done properly. With the column family, new columns can be added dynamically and rows can be sparse. That is, the rows does not need to have a value for every column. You see here, right? Say the first has two columns, two rows, and the second has three rows. So it's not necessary that the same structure is followed across. So unlike a key value store or a document store, most column family databases physically store in key order rather than by computing hash. So there you saw, right? The key was general. 90% of the cases it is a hash computation. It's just a hash value which the system will generate for that particular record. But here we don't do that. We actually have a physical value. Row key is considered as a primary index and enables key-based access via a specific key or a range of keys. So here with these keys you access it. So there you have do it with the hash value. Here you access it with these keys itself. So what happens is on disk all of the columns within a column family are stored together in the same file with a certain number of rows in each file. So when we look at how the data is stored, okay, what they do not keep the columns in in a different disk or in different files. One single file will have all the data. Only thing will be columns will be grouped in column families. It's not like they are will be stored separately also. Okay, so read and write operations for a row are typically atomic within a single column family, although some implementations provide atomicity across entire row spanning multiple column families. So here the atomicity is also maintained. Okay, and then with the large data sets, this approach creates a performance benefit by reducing the amount of data that needs to be read from the disk when only few columns are queried together at a time. So where do we use it? Okay, this will come in a picture where you have huge amount of data, but you need not access everything at a time. You will just access something based on a query. Say we just want to access data of people who have logged in into a web page from 7 a.m. to 8 a.m. We just want that data. In that kind of scenario, you can get it here. So something where you get your data in a very not in a particular in a yeah,
Then
good.
so I was asking like this column data stores is basically used in Cosmos DB or like
No, this
this
is
we're
not
talking about
Cosmos DB. This is not
relational
Cosmos DB.
database, right? You're talking about
No,
relational database, right?
no. Please don't get confused. This is a non-relational database. Relational database, your row is your granular level. Here, your column
Okay.
is a granular level. Okay. The only
Okay.
thing is, this is conceptually you can relate it. It looks very similar because you have a primary key and then you have this column family and all. But it is not the same. See, here what will happen? Although these things are shown in different ways, right? Column family identity and all. I told you on the disk, all the columns will be stored in a single file. Okay, it just looks similar to RDBMS, but it is not. So whenever there is a sparse data and we don't need to access the complete set of data, we can use this database comes into picture. And you're asking for the relevant one, then it is the Azure HBase in HD Insight. So HD Insight is something which is used to query your big data. In that we have a database called HBase. So that is basically your column data store.
Okay. And what is SD Insight?
HD Insight is basically an application that will help you connect to your big data.
Okay.
Inside is
Okay.
a platform on Azure for the big data.
Yes, better way to say it.
Okay.
So, one second.
So
Show
again,
you.
the same question comes here. So SD Insight is a platform given by Microsoft, and this will come under PaaS, right?
See, if you go and consider data factory itself, it is PaaS plus SaaS combination. All right. So
Okay.
yeah, this is a platform. This is HD Insight will be a HD Insight cluster is the platform.
Okay.
Okay, you have to set up the cluster and then you have to connect it. All right. Okay. So this is the relevant one. Here again the data is denormalized. Schema is column families defined on write, column schema on read. So what happens when you write the data, the schema is defined, and then when you're reading from some source, so before reading, you send the column information and then they read it. Okay, consistency across concurrent transactions, column family level guarantees. So you see here, right? This consistency will come only when it is happening in different concurrent transactions. Only then this will come into picture. So the column family level guarantees. This means that since these are segregated like this, it is maintained that the consistency is there. You cannot update. It will not be a case that there is an update happening, but someone else is reading something else. Okay. The atomicity is a table over here. Locking strategy is pessimist, unlike optimistic, which was in document DB. Access pattern is it aggregates on tall, wide. It aggregates on the wide data. So we'll access based on aggregation over here, and it supports both primary and secondary indexes. Data shape is it is tabular with column families containing columns. Remember, RDBMS is tabular, but there that we store data on rows. Columns just define the data like it gives the schema details like the structure, but the actual record is stored in rows. Okay, the data is sparse. It is wide, that is with lots of columns and attributes. So the data size here is medium to large. Document DB was used for small to medium, and overall scalable is very large. Okay, so we are done with two types of document DBs. So next is the key value data stores. So again here the Cosmos DB comes into picture. The key value store is essentially a large hash table. Okay, you can see here, right? There is a key, there is a value. Value is a hash and key is a randomly generated key. Again, each data value is associated with a unique key, and the key value stores uses this key to store the data by using an appropriate hashing function. Okay. The hashing function is selected to provide an even distribution of hashed keys across the data storage. Okay. So due to the since it is hashed, the distribution will be done evenly. That is one of the benefits of getting the values, creating a hash key for each of the values. Most of the key value stores only support simple query, insert, and delete operations. Because imagine with something like this, it is very difficult to do an update, join, or any kind of complex queries. You can do a select, you can do an insert, or you can do a delete. Imagine if what if you have to do an update. So you have to get to the key, you have to read the hash value, to get all the value from that, then only you can go and check which particular field you need to update or which particular attribute you need to update. So that is not supported. So it supports very simple query like select queries, insert, and delete operations. To modify a value, an application must overwrite existing data for the entire value. So what happens, suppose there is an existing record, the employee record. I just want to update his title. I cannot do that. I cannot go and update one single value. I have to override the entire thing. Because see, you for the entire thing one hash is generated, right? Even if you change one value, the hash changes. The other, even if the other things remains constant. So this type of database, you if there is any kind of update, it does not goes and update that record. It removes the entire record or it updates the entire record. So in most implementations, reading or writing a single value is atomic operation. If a value is large, writing may take some time. Okay, so either it can read or it can write at one particular time. Okay, so the data stored values are opaque to the storage system. You're even in the system, they cannot see the data. Okay, so it's not like it's visible here. This is how the data will be stored. So your data will be actually, it will be hashed and then it will be stored. Any schema information must be provided and interpreted by the application. So what happens when you want actually going and with that details, it will fetch the data and display it. Essentially, values are blobs and the key value stores simply retrieves or stores value by key. So blobs is one thing which the this type of storage is used extensively in your Azure, in Azure. Okay, so there is something called ADLS2, that is Azure Data Lake Storage 2 is the new version. So initially there was Azure Data Lake Storage 1 and then we had blob. There's something called as blob, that is binary, the data is stored in that format. Okay, key value stores are highly optimized for application performing simple lookups using values of the key or by range of keys. So it's evident, right? Because there is a single value, the lookup functions will be very very fast if you're using by one key or say two or more keys and you're doing kind of a lookup. So in that kind, so relate a scenario we need when these kind of issues will come, or when we want to do when we want to mask the data. It's okay for us not to have an update operation, or we can up, or it's okay if we have on the entire row gets updated at, if a single thing has to be updated, we are okay with that. And we need to do a very high performance lookups, then we use this kind of database. They are less suitable for systems that need to query data across tables, different tables with key values. So joins are again not easy here, because you want to join on something inside this hash value. Okay, so as I was saying, it should go get the key, get the hash value, then from there it should again get the records, match, again search in the other table for the hash value. So it's a very, very complex, expensive and tedious method. So we do not use these kind of things here. A single key value can store extremely scalable, as the data store can easily distribute data across multiple nodes on separate machines, because everything is in a hash value. It's very easy to scalable, you can easily distribute the data, and since it is hash value, the distribution will be done evenly, as I was saying in the beginning. So your relevant one is Azure Cosmos DB Table API, Azure Cache for Redis, and Azure Table Storage. So this is another kind of storage which is provided by Azure. All right, so if you want to see, show you in the portal something like a storage account. So if I go and add over here, okay, okay, when the reason I have not created anything like a resource group or anything, because first time I'll create it with you guys so that you can get an idea. Now here the requirements are, again, data is denormalized, schema on read. So whenever we are reading the data, we need to provide the schema beforehand and then it will read. Now consistency is maintained by your key level. Atomicity is a table. Locking strategy is again optimistic. Access pattern is random. It supports primary index only, unlike the other two where it was supporting both primary and secondary. Here only primary index is supported. Data shape is your key value pair. This also supports sparse data, but it does not support wide data. The data size is again in this it is small. So you can see, right, based on what is the size of your data, again your kind the NoSQL types are different. So when we design a database, when we want to understand which kind of NoSQL DB to use, or you want to use Cosmos DB only, but which API to use for that Cosmos DB, we have to understand what kind of data we are dealing it, whether the data which is coming is small in KBs, or it is medium to large, or it is small to medium. Based on all those things, this is how the designing comes in picture, that which database or which NoSQL DB you have to use here. And apart from all this, you always have to consider the cost as one of the major factors also. Next is the graph data store. So this is an interesting one. Okay. A graph data store manages two types of information, nodes and edges. Okay. So you see there are nodes and then there are edges which are connecting these nodes. Nodes represent entities and edges specify the relationship between two entities. Okay. The purpose of a graph data store is to allow an application to efficiently perform queries that traverse the network of node edges and to analyze the relationship between the entities.
Like, is a MongoDB the only document store DB, or do we have any more of them?
There are more of them,
To
but
the
that is
count
the most
videos.
popular one. Sorry, someone was saying something.
Couch DB.
Yeah, but MongoDB is more popular, so that's why we have that. Now we were going through the graph data store, so let me tell you the best example to understand this will be your Facebook. Okay, here we have an example with the employee, and it's showing the department. So I'll quickly explain this and then I'll show you how you can relate it to Facebook. So employee one is there, name is Ajay, so he works in this department called head office. Then there is another employee called Sumit who reports to Ajay, and he works in another department. Similarly, there is an employee called Tarun who again reports to Ajay, but he works in marketing. So you can see, right? Now this is a little complicated. Let's take the example of Facebook. Suppose I I am user one. I have uploaded a photo. Okay, in my photo I have tagged two other people. They are user two and user three. So there are three people. Now user four, who does not have any relationship to user two and four, has commented on my photo. Okay, user five, who may know user four, has again shared my photo. So you are getting it right. There are too many relationships which are interlinked, and it's not related that every relationship is linked to the every other relationship. So in this kind of picture, this is the best possible way is to do it through this graph and edges, nodes and edges. Does it make sense? Do you get at least a vague idea of what how it is related, how the relationship is done in this?
So is the employee like the header is the node and then the associated one are the edges to it? How do we
No,
see that?
see, this employee and this name is a no is a the relationship. Basically the relationship is the edges, as you can see here, right? Edges specify the relationship between the entities, how employee Ajay and department head office is related. So this is his, if I search for an employee Ajay and if I search where he works, the department should come up. If I suppose search for Ajay and I want who reports to him, Sumit and Tarun should come up. Suppose I want the employee Ajay, I want who report to him and from which department. Then it should display as Sumit who works from sales. So your name, employee name Sumit, department sales should come. Again, employee Tarun and employee marketing should come, as well as employee Adarsh and department manufacturing should also come. Okay, all these three should come. Remember one more thing. See, there is here an employee called Prakhar, right? He reports to Tarun and he works in marketing, but it's not related that he will again report to Ajay. It's not necessary. Okay, that how in RDBMS we have parent-child relationship, right? That is not over here. It's not necessary that Prakhar is related to Ajay. He may not be related to Ajay. He may completely do it to some other person.
Got it.
Okay. The entities are employees and the entities are employees and departments. The edges indicate reporting relationship and the department in which the employees work. In this graph, the arrows on the edges show the direction of the relationships. That's what I'm trying to say. That okay, who is whose employee and all. So that's why I tried to give you the example of Facebook post, since I was able to relate more to it. Because see, someone who is commenting on your post and someone whom you're tagging on your post, they both may not know each other, right? You know both of them. So that is the thing. So here the data is normalized. Okay. Schema is again schema on read. Consistency is graph level consistency, and atomicity is also graph level. They do not have any locking strategies. Access pattern is random. Here again, both your primary and secondary indexes are supported. Data shape is graph, which contain both edges and vertices. It does not support sparse data. It does not support your wide data. Data size is small. So, and overall size is scalable. So the amount of input we are getting, right? They're small datas. Okay. Relevant is Azure Cosmos DB with your graph API. So I'll show you. If you go over here and if you create an ad, so here if you see, there is this gremlin, right? Gremlin is basically graph. And you were asking for document, right? This is the one, Azure Cosmos DB for MongoDB API. And then you have Cassandra and you have your Azure table, which is the column database. All right. So this is one feature, that you can have one Cosmos DB, but then you can access it in all these different ways, however your requirement is. So the next is time series data stores. So basically the four we studied are the major ones. These are kind of these are also important, but they are basically they hold the main four. They are the main four types of partitions. Okay, sorry, main types of NoSQL databases. So next is the time series data stores. Time series data is a set of values organized by time, and a time series data store is optimized for this type of data. Wherever your time and time series comes in picture and you want to organize your data on that, that is the basis of your data organization, this type of NoSQL database is used. These data stores must support a very high number of writes, as they typically collect large amount of data in real time from large number of sources. Time series data stores are optimized for storing telemetry data. So when you get lot of information, say from when you're reading data from your IoT devices, and something which is sending you data very frequently, a lot amount of data is there, and again you want to organize on timestamp level. You just bother to understand how much of input you are getting between this particular time and this particular time. We go for this type of data store. Scenarios include IoT sensors or application system counters. Updates are rare. Deletes are often done as bulk operations. Okay, so here again we do not support updates. Can be done, but it's better not to. And deletes are often done as bulk operations. So the entire huge sets of records will get deleted because it will be based on your timestamps again. Although the records are written to a time series database are generally small, they are often a large number of records and total size can grow rapidly. Now we have Azure Time Series HD Insight and OpenTSP with HBase on HD Insight. These are the two Azure relevant series data stores. Okay. Here again, the data is normalized. Schema will be when we read the schema. Consistency, atomicity, locking strategy, they do not it's not relevant to this type of non-relational database. Again, it has a random access and it does aggregation. Both primary and secondary indexes are supported. Your data shape is tabular, does not support sparse and wide data. This is again useful for your small data size, and this is again scalable but not as huge as the other databases. There you could see that when we checked for scalability, it was in TBs. Okay, here it is low TBs. And the first one which we saw was in petabytes. The next is your object data stores. So the object data stores are optimized for storing and retrieving large binary objects or blobs such as images, text, videos, audio streams, large application data objects, and documents and virtual machine disks. So what happens? You get data from your social media, right? You can have anything, text, video, audio, or documents, images, virtual disk images. What do? Do you have a different kind of data type for each and everything? Instead of that, there is something called object data stores or blobs. Any kind of thing, you can just store it as a blob. It supports all of this. It supports your text documents also. At the same time, it will support video also, audio also. So how easy it will be, right? You can take any kind of data store, you can store it as a blob, and then you can take data from there, do your transformations. Okay, so an object consists of the stored data, some metadata, and a unique ID for accessing the object. Okay, so this will be it. This is the path where your blob is, or from which is getting read in the blob. Okay, this is your blob, and this is when it is created. So here we are reading a CSV file called flights.csv from this particular folder. We are reading it and we are storing it as a blob, and that was created at this particular time. Object stores are designed to support files that are individually very large, as well as provide large amount of total storage to manage all files. So when we are dealing with large data sets, right? Because see, your images or your videos, they may be huge. So this comes into picture.
So in what
Now,
format would it be saved in blob? Like, is there a particular format it will be saved in?
no. I will come into that. So basically, it will be stored as a binary. Just one second. Just let me get you the full form. It is
Okay.
binary large. Yeah, a binary large object. Basically, it will be stored as an object only. Okay, how it internally gets stored and all, we do not need to get access to that. We just have it is enough if you know when to use it and when you can get it, because it is very very complex, and we do not even have the access to design it. First of all, we will not Azure will not give. You can just select if you want to store it as a blob, and while reading it, you can read it from there. You cannot customize those things.
Okay.
So one special case of object data store is network file share. Okay, So what happens is you'll get something as a network file share. Using the file share enables files to be accessed across network standard protocol, standard networking protocols using server message block. So what happens if SMB is supported? Okay, you can just use a file share. So this will help you to mount your create a mount, and then suppose from your on-prem, if your on-prem is supporting the SMB, you do not have those firewalls and your organization is okay to share data through this protocol. What happens is if you do a file share, it will create a mount on your on-prem file structure, and whenever you upload a file over here, automatically you can see the files over there. So this is a very good feature, but only thing is if the organizations or our organizations or the privacy level should be set that they allow for this thing. So here three things are there: Azure Blob Storage, Azure Data Lake Storage, Azure File Storage. Okay, so all these things comes in picture whenever we create a storage account. This again data is denormalized, schema is on read, consistency is not applicable here because it will be used for storing, and the access when we access from blob, usually we do it for our internal applications, like I was telling about data factory, right? So what we usually do is we push all our files as blob or as ADLS2. We'll go through it. The next one I suppose is ADLS2 or ADLS. We push it as that, we store it in that way as binary images, and then we read data from there and do the transformations. What good thing is that any kind of data, right, we can just put it in a blob. Suppose we want to store read one CSV, and we want to read one Excel, and we want to read one JSON. All three we can store it in different blobs. We can read from them at the same time and we can join. We need not do any kind of conversion. Locking strategy is pessimist. Access pattern is sequential access. Okay. It supports only primary indexing. It has a blob where the data is stored and a small metadata related to it. Does not Sparse is not applicable here. It supports wide data. So here the data size is large to very large. And overall scalable, it is very large. It's in petabytes. Now external index data store. Okay. So your external index data store provides the ability to search for information held in other stores and services. This is very useful if you just want to search a particular data where it is. An external index acts as a secondary index for any data store and can be used to index massive volumes of data and provide near real-time access to these indexes. An external index lets you create secondary search indexes and then quickly find the path to files that match your criteria. You can build a secondary index based on the values in the data and quickly look up for the key that uniquely identifies. So you have an ID and you create a search document with these kind of details on which you will be searching a particular data. Say a data set has a lot of data, but you know it will be always searched on a name or on a country or location. So you create a search on this and then search is maintained. So there is something called a function there is called as Azure search. Okay, so whenever we create Azure search, this comes into picture, and this is very important when you want to search something in the big data field. So that is why we are going through it. So this is here the indexes are created by running indexing process. So when we create the Azure search, we have the option to do it, and different kind of models are there. And okay, so I'm just skipping this for now. So I'll quickly proceed with creating it. So I'll show you what it is. Okay, so firstly, one thing, everything we do is at the subscription level. Okay, resource group is something where we will be creating up, like suppose consider you're creating for one particular project. All things created for that project, we'll put it in one particular resource group. Say we have a project, or say we have a requirement wherein we will take a CSV file and we will load it into Cosmos DB, and we will access it through say Power BI, which is a reporting tool. So everything which is related to all this will be created in one particular resource group. So first and foremost, we'll go and we'll create a resource group over here. Since my free subscription is over, so I'm using this subscription. For you, the free should come over here, free or trial. Okay, so I'm keeping it as training. Region is okay. So there are these many regions. I suppose you will find in Asia as well, and all these regions are there. So one thing, uh, most of the resources are available across regions, but some resources are not available on all regions. So in case you do something like you that is not there, a pop-up will come over here saying that this particular resource is not supported in that region and you need to change the region. Okay, so next is something as tags. So tags is kind of a metadata. Like suppose you are creating, as I said in the resource group itself, something you are created for database, something you want to create for reporting. So what happens? You want to create it. This is related to your database which is holding department data. So I can just put a tag as department. So it is kind of, it will help you to I'll just, as of now, or we can skip it. It's not very important, but in order to filter out your data, this is very helpful. So I'll review and create. So you see over here, right? There is no a subscription fee or no payment, or there is nothing, no chargeable here. So this is kind of free. So I can just go ahead and I can create. So your resource group is, so on this bell icon, you can actually see what all activities are happening and whether it is working or not, whether it has been created or not. All right. So I can just click over here and I can go to resources, or else if I go to home now and if I click over here and see all resources, actually it should come over here. So let me see, leave it, I'll go it from here, go to the resource group. So it is showing my resource group. Okay. Now let's create a Cosmos DB. So you can actually go ahead here and create inside, you can actually go inside your resource group and create from here, or whatever you want to create, you can search in this search bar, or else you can go over here, you can create a resource. So it lists down everything. Okay, so these many kinds of softwares or applications are provided. If you want, so there is this machine learning studio. In analytics you will have the data explorer, HD Insight, data lake analytics, stream analytics jobs you see over here, right? And with each of the thing, right, you have a quick tutorial. So it actually it is very this is a very good way in Azure. So it provides you how, at least a basic look and feel of how it looks. Okay, how, see, the basic of how to be created and all these things are there. It's good if you want to study on your own also. And this is like the Databricks, this all comes under analytics. You have your compute, where you have virtual machines. If you want to create Kubernetes services also, you can create here. Then there are other things. Then there is this networking, where you can create virtual network, load balancers, application gateways, firewalls, all this you can create over here. Okay, so here you can see software as a service, what are what are the softwares that are provided. Then you have the security. Okay, then again we have the storage. Okay, there will be a database. Here we have all kinds of databases. You have SQL database, you have Synapse, which was previously called SQL Data Warehouse. You have MariaDB, MySQL, Postgres, Cosmos DB, Cache. So all these kinds of databases are there. Whatever you want, so there you can just go over here, create a resource, and then you can search in the search bar, or else directly go over here, search for whatever you want to create, it'll come. So let's go and add one Cosmos DB. So my subscription will come over here. If you have more than one subscriptions, it will list. Okay, and you have to select which one you want. So since I created the only resource group I have here is this, so it is showing this. In case I have not created, okay, so here and or I don't want this particular resource group, I can clearly go ahead, type a new name here, it will work. Now one more thing is, names cannot be repetitive. Say if I give the same name, so you can see here, right? A resource group with the same name already exists, so it will not allow. Okay, again there are okay, so it is allowing. So there are certain naming criterias also, where some of the places you cannot use certain special characters and all. Every time you do certain things, a pop-up will come up like that, or and it will say for what reason it is not acceptable. All right. So this will ask for your account name. Okay, so we are clear up till this point, right? So next is your account name. You can give any DB name you want. Just let it be little relevant. See, the name is not available, right? So Cosmos DB, if I give Cosmos DB training, is available. Oh, this is also not available. Okay. So this is available. All right. So similarly, so this is for training. So I kept it. So then keep relevant names, or mostly in organizations, they will follow a naming structure, because only then they can have multiple things in place. Now, for now, we'll be creating a core SQL this one. So this is like, it will enable your Apache Spark with your Azure Cosmos DB account. We don't need it for now, because, or else suppose you want to use Spark directly on this. So what will happen is, when we sign up for Spark preview, there's something called as notebooks. You can just consider it as a set of code. So it will enable that, and you can use it in Databricks or in some other place where you want. But as of now, we are not setting it. Location, we are just keeping it to the same location where we created our resource group. Okay, one more thing is, see, if you try to create your resources in the same region, what happens is, if you are creating resources in different region, right, your latency comes into place. And then there may be a, like, since we will be creating everything with the lowest configuration possible, so definitely there will be a lag. So that is one. Just remember, even if you are doing it in your office or for any official need, try to maintain everything in the same region. So this is a suggested approach by Microsoft also. So we are not taking any of these. So geo redundancy is something wherein your data will be replicated in the same region. This is for multiple region, and this is across zones. Not only, it will be in different countries. Okay. So as of now, we don't need any of them. Next is your networking. So you see here, right? Whether you want to put networking or you want to do it from public endpoints or selected networks. So this way you can start at this point itself. You can start blocking things. You need not do an all network if you don't want. You just can create a, you can just give which public endpoint can select it. So here you have your, then you can configure your firewall. Okay, allow access to automatically the IP which I'm using is shown here, and virtual network, and all this will come into picture. So for now, let's do it with an all network. Next is tags, which I will again leave it. So when I go here and do a review and create, right, see a cost will come. Okay, so Cosmos DB, this is the estimated creation time. This is taking 11 minutes for me. So Cosmos DB, it does not comes the cost now. So it's free to create a Cosmos DB account. When I go and create something inside the Cosmos DB, then it will ask. Okay, so let me go ahead and create a Cosmos DB. So while this is getting created, let me create a storage account. Okay, again the same thing, we go to add. All right, so there are,
Hello. Yeah, yeah. So let's say I have already created a storage account once, so I don't have to
Mhm.
create another one, right?
No,
I
you
can use
need
the
not
same
create.
one.
You can use the same one. Since I have not created
Okay,
anything, I'm creating it. You can use the
understood,
same.
understood.
Hmm.
Okay, thank you.
So let me keep it as training storage account. All right, let me keep the same. Now here, what kind you need? Okay, whether you need storage v2 storage or you just need a blob storage. So remember, blob storage is used only for your virtual machine images when you want to store that. Generally we keep storage v2, which is it has certain amount of features, and this was the existing general purpose v1. So we generally go with v2. Okay, now performance. So there are two options available here. One is standard and one is premium. Standard storage accounts are backed by magnetic drives and provide lowest cost per GB. Okay. They are best for applications that require bulk storage or where the data is accessed infrequently. Premium storage accounts are backed by solid state drives and offer consistent low latency performance. They can only be used with Azure Virtual Machine Disk. So, whenever you use a premium one, you need to access it through a virtual machine disk, and are best for input output intensive applications like databases. Additionally, virtual machines that use premium storage for all disks qualify as 99.9% SLA. So your Microsoft, it provides SLA for each and every application or resource. Okay. and it always maintains that. So in case anytime Microsoft fails to do that, it is supposed to pay you for its losses, and there are different ways it does. Sometimes it provides you credits and all based on which resource and what is written in the SLA. So the
Sure.
next thing is replication. So the data in your see here we have these many kinds of replication. Locally redundant storage. Locally redundant some storage is something it will do locally in the same place where your DB resides. This is in zone. This is again your geographically different regions. Then geo read access geo redundant storage. So what happens, these storages are there, right? They will be there but you cannot access them. They will just come up when your failure happens or for recovery. But this one what happens, right? Even the replication also you have a read access. Okay, again the same thing, geo redundant, geo zone redundant storage. Okay, one more thing, you can see these are preview is written, right? So this is something like Microsoft has added it recently and it is a preview feature. So in this case, even if you select it, you will not be able to access all the features. So it is something like they are providing the users, and if someone is using it, and it's kind of a testing going on also, they are also testing it their end, and we are also using it and testing it on our end. But in preview features, SLAs are not considered, and at the same time all kind of whatever your features should be there, right? They may or may not support everything. Okay, we don't need so we'll not select premium, we'll just keep it as standard, and we'll just keep it as locally redundant storage because we and remember, with everything comes a cost. If I put premium, it will be expensive. If I put more replication, it will be expensive. If I put a replication across different countries, it will be expensive. So the expense rises at that time. Now there are two kinds of access tiers, okay, cool and hot. So this is completely based on how you want to access the data. So the very good description is given here itself. The account access tier is default tier that is inferred by any blob. Okay, see, the hot tire access tier is ideal for frequently accessed data, and the cool tire is ideal for infrequently accessed data. So what
So data
happens?
temperature, data temperature we are talking about, right?
Yeah, sort of. So yeah, the way we will access the data, we'll read the data. Okay, and how they are charged is in the cool data tier is there, right? Which is not used frequently. So what happens here? Storage is cheaper, but the access of data becomes expensive, and your Microsoft will not, no, it does not provide how much it is charging at each level. Okay, so next, finally one price will come up. Next we go to networking. So you can select public, or you want selected networks, or you just want private networks. So if you see, if I give selected networks, right, again I need to create a virtual network. So lot of things comes into picture. When I create a virtual network, it will ask me for your address ranges, subnets and all. But the reason I showed you is, see how properly we can actually secure our environment, right? So, and again, even if you're still you don't want to do that also, you can just put a private endpoint just so that only the one you are allowing they can access.
And when will we use public endpoint and private endpoint in real-time scenarios?
Mostly we will use selected network. So all your organization will never allow you to use public endpoints. Okay. What will happen is, first of all, 90% of the ports will be blocked. So internally itself, to access from there to cloud, you need to have certain endpoint setup. And also, whenever you create something in Azure, I'll show you. One second. There is something called as Azure Advisor. Okay. So what happens there is, it will give you for each resource, it will give you this one, what kind of security features or something it is lacked. So Azure itself will come up and suggest you that your this particular resource is not connected to any virtual network. So it is very important that you create a virtual network, you define your end subnet, you define which, you set up the firewall, you define what has to be accessed, and you connect it to a resource. So whenever in 99% of the cases, only in demos, I think we will use all networks. Or if your application is such that you want anyone to access it, say you are creating a website, say you are just creating a home page for your organization and you are just displaying some data and you have no issues if anyone can access. So there you will put public endpoint. But if you have any kind of important data, it will definitely go via virtual network, VNet, firewalls. And these are just few levels of securities. Okay, there are other kinds of encryption also which are in place. So either you can and one more thing is, even though I'm not defining it here, right, later point I can create a virtual network and I can go ahead and add it. Okay, next is advanced. So you see here, security, secure transfer required. So what this suggests is, when we are transferring the data, whether the data is secured or not. So it will give, we are putting it as enabled. And the rest of the things, it is Azure large file shares. So we don't need it at this point of time. But suppose your requirement is such that you want to share large data across, right? See, large file storage accounts do not have ability to convert to geo-redundant storage. Offering an upgrade is permanent. This you cannot change back. Okay, and here you cannot have geo-redundant. So this is all based on your requirement. We do not need this. So blob soft delete. We do not need this soft delete operation. We can directly go and do a hard delete. And then you have hierarchical namespace. So if you do this enable, your data protection cannot be enabled simultaneously. You see this, right? So we keep it as disabled. What exactly it is this comes in picture in your ADLS Gen 2. So currently most in the newer version we'll always be using Gen 2 only. It is a hierarchical namespace that accelerates big data analytics workloads and enable file level access control list. So this is something related. This is related to your big data. So when you deal with that kind of data, right, and you want to store your data in hierarchical level, you will select this. But as of now, this is not required. And see here, you need a different subscription to use this feature. Okay, since mine is the lowest one, I have taken just after free, whatever is there, this is the one. There are various different kinds of subscriptions. So if you go ahead and go for the higher ones where you have to pay more, you will get all these things. Okay, so next is tags. So next is tags, and I'll just skip the tag. So here we have the review and create. All right. So So you see here, right? Both of them are created. Your storage account is also created. Your Cosmos DB is also created. All right. So as I told, either we can go here, or if the data is refreshed, I suppose it will show now. See, now the resource group started showing. There is a little lag, but usually all the things which you create here, right? You can access it over here. Okay. So let's do one thing. Let's go to our Cosmos DB. Okay. So your deployment is complete. So this is your Cosmos DB. And you see Microsoft.document DB. We have entered the Cosmos DB. So let's see the overview. Overview, what all it is testing. Firstly, the status is online. Okay. Resource group is this. Subscription is this. Subscription ID is this. Where is the locations and what is the URL? Please remember, if you want to connect it to, suppose you want to connect it from on-prem Power BI, you need this particular URL. If you using this, we can connect it from different sources. Okay. Now there is something called as activity log. So whatever I will do, it will show here. So currently what I've done, I've just updated database account 5 minutes ago. So the details are there. It is initiated by my account. Okay. Access control. This is one important thing. Okay. So what happens is there are different kinds of roles that are assigned. Okay. So based on your name, you can see the roles that are assigned over here. Since I am the owner of this, I will have all accesses. Okay, I will have the admin access since I am the only one using it. Usually in organizations, what they will do, they will give you contributor role. So you won't have access to add. Suppose I want to add a role assignment or I want to add a co-administrator. I can do that. If I go ahead, if I add a role, now what Azure will do is there are many different kinds of roles. Okay, see, app service, data factory, all this. Suppose I create a data factory and I want to give access to you all, but I don't want you to have access to any other resources. So I can go and get this predefined role. I can search your name, but you should be in the same subscription, of course, and then I can give you the access. This is how things work in organizations. So this is a very will learn in detail. So this is called based access control, RBAC. So
And
what
when
is it is?
when you say they need to be in the same subscription, so they need to have access to the subscription, right?
Yes.
They
Again,
the subscription.
hmm. Go ahead.
So
Yeah, they
you
have
have
to access.
yeah. So how do we maintain that like access level or the security? How do we give access at the
So see,
subscription level?
that is again on the admin, since I am the admin over here, but I'll tell you how it happens. Okay, so I have to give access. So what happens, I can go ahead, I can add users. When I add user, now usually if I add user, I'll add the user and your ID password. There I can again enable multi-factor authentication also. Okay, so there are different levels of authentications which I can do, but it is on the admin to add a particular user. In your organization, they'll never give you admin access. They'll always give you a contributor access because they want to control who has access to what. And if it is a payable account, then definitely it will be someone else.
Yeah, but which screen would have that? Like where
Okay, that will be in a different place. So I'll show you. So that will be at the subscription level, all right. So if you go here and if you search for subscriptions, pay as you go. If I click on the subscription and if I go and control access based control over here, and then here if I do a co-administer, it'll be at the subscription level. So you getting access at the subscription level.
So if I
If I
have
go,
access at the subscription level, it doesn't mean I have access to the Cosmos DB, right? I still
you
have
will have.
to. Oh,
No,
I'll
no,
have
you will
if.
have. If I give you a contributor role, if I give
Okay.
you a subscription and then if I add you to another role such that it restricts to the Cosmos DB, you won't. Again, apart from that, there is okay, let's go to our Cosmos DB first. So you can go to your data explorer over here. All right. So, and one more thing, in order to save your cost, please delete all the resources you are creating. All right. Because whether it is running or not, they will charge you. So here you see there is a new container, there is a new database. So let me create a new container. I can create an ID, say, so just the database ID. A database is an analogous to a namespace. It is the unit of just a namespace. Okay, just let me give it as a test.
Again, you said delete the resources once means every time. You mean
Yeah, once you are done with the work, if you want to save cost, please go ahead and delete the resources.
suppose I have created Cosmos DB now, used
Hmm,
today, and
hmm,
again I want to use it again after day tomorrow.
hmm.
So should I create it again?
It is my suggestion if you want to save cost, because you will use it after 12 to 13 hours only, right? At least after if you use immediately after waking up also, then you will be paying up for at this entire 12 to 13 hours. Okay, so just I'll show you with the container thing.
So even if we use or not, if we have it created, they'll start charging, right? The
Cosmos DB is
resource group.
charged. Resource group is not chargeable.
Okay.
Storage account is again chargeable. See, you see here, starts at $24 per month per database, multiple containers included. Okay, so if you go over here, you can start getting the pricing details. All right, so let me create a test data set, and this is how it is measured. All right, so every database, what they have done is they'll give their own units. Okay, here it is called as throughput. If you go for database, it will be DB units. If you go for data warehouse, it will be DW units. So this is a combination of different things: storage, computation power, redundancy, region, all that we have selected, right? Based on that, this will come.
Container is equivalent to what? Not a schema, right?
No, 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 no. There is no schema.
Inside container, we can have multiple database, right?
Yes, we have. That's what I wanted to show. See, I created a database ID, right? Let me create a test container. Actually, you can, the display will be good. And here I'll just give it as ID. Okay, any random ID. And see, for 400, I'm spending 32 hours, 0.032 hourly, or 7.77 dollars daily. If I increase it to 800, it has changed. If I increase it further, it has changed. But as I increase it, the performance will increase. There'll be a huge difference.
That is called RU, right? Request unit.
Request unit, yes. Here it is
Yeah,
called
that is
request
major
unit.
request.
The partition you have provided, I mean, it can be anything.
I kept the ID. Here you see, right? This is your container. Okay, this is your, sorry, this is your database or container. If I add a new container, again a new one will come. And sorry, this is your database ID, which was test, and your container is test container. I can add another container here, test container 1. Okay,
Container is
and
like
again I
a
can give a,
schema or something.
no, no, it is not a schema, it is like a
It's like a table.
matlab logical grouping kind of. See, this here it
Yeah.
came, right? Inside this will be your items. Currently it is all empty. So suppose I will
Hmm.
upload, I can
And is it
upload a
Okay.
storing it as a key value now? Because we have read about data stores, right? So right now, is it like key value?
it is not key value. It will show your data. It will not put a hash. But yeah, the key will be a hash, but it will not have that complete value as the hash. Okay, and you can actually, if you do a query, there'll be something over here. So if you do a select star from C, okay, and if I want to put a filter over here, I can do it where any kind, like see, where CID container ID equal to 1 or any field. So here the data will be displayed. Okay, so you have, like, this is the table, and in this you will have, how do I explain? This is actually one table in which you are having multiple columns or multiple rows if you want to put it in an RDBMS format. And in this again, you will have many more things. This, I can upload one document with say 100 records also. So everything will be updated here. If you want to upload an item, it's very simple. So select JSON file. You need to create a JSON file. You can get online many JSON simple. If you just Google it out also, simple JSON files, you can get it. You can just go ahead. It'll open from your local system. Go ahead and do it, and it will upload and it will get uploaded. It's very simple. So I just wanted to show you one thing. And then see here, you have containers, file shares, tables, and queues. Okay. So when you open, this is the storage preview. You have your blob containers and you have file shares. You have something called queues and tables. These are the Azure tables. So everyone was asking me about the blob containers, right? So if I want to go here and I click on containers, you can just go ahead and create a container, and it will be a blob container.
So Cosmos DB container, this container is different, right?
Different.
Both are not same.
Yes, yes. No, no, both are not same. Both are
This
not same.
container is for
This
storage, right?
this is for blob storage. Yes, this is for blob
Blob
storage.
storage, right?
Correct. Cosmos DB is different.